Antidifferentiation is also called integration. So firstly, what is antidifferentiation? Antidifferentiation or integration is about reversing the process of differentiation. We have already studied differentiation. If we reverse the process of differentiation, that is called antidifferentiation. The derivative of x squared plus c is some constant. So derivative of x squared plus c with respect to the variable x, we know is 2x. Now if we reverse the process of differentiation, in other words, the antiderivative of 2x with respect to the variable x is x squared plus a constant. So we know that differentiating x squared plus c results in 2x. Now if we reverse the process of differentiation, if we take 2x and anti-differentiate that function, we will obtain x squared plus a constant. Now anti-differentiation can also be written like this. Anti-differentiating 2x can also be written as the integral, that's the integral sign, of 2x with respect to the variable x. So we write dx. So here we are saying the integral of the function 2x with respect to the variable x is equal to x squared plus c, where c is some constant. Alright, so let's now look at the rules of integration. So suppose that we want to integrate a raised to the power xn with respect to the variable x. The integral of ax raised to the power n, now before we present the result, we need to note that a is some constant, for instance phi, and n is also a constant, for instance 4. So a and n are some constants. So the integral of ax raised to the power n is ax raised to the power n minus 1 over n plus 1 plus some constant c. So let's see how the result was obtained. The coefficient a on the left hand side remains the same on the right hand side. So the coefficient a does not make a difference. If it's present on the left hand side as a coefficient, it is still present in the result, final answer. X raised to the power n, in integrating we look at the index n, we add 1 to that, so n becomes n plus 1, and we divide a times x raised to the power n plus 1 with n plus 1, and we add a constant. Note well, this result is applicable for n not equal to minus 1. So let's take a look at an example. So here we want to integrate phi x cubed. So integrating phi x cubed, this term phi will still remain the same. The index is 3, so we will add 1 to the index, so 3 plus 1 is 4, and we divide by the same number 4 plus a constant gives us the integral of phi x cubed with respect to x. So let's look at another example. This coefficient 10 will remain the same on the right hand side. The index is 4, so we would add 1 to that index, so that will be 5. Divide by 5 plus a constant. So we can simplify this to 2x raised to the power 5 plus a constant. Let's look at another example. Here we're looking at x raised to the power minus 3 dx. So the constant coefficient in front of x is 1. So that will remain the same in the final answer. So we look at the index. Index is minus 3. We add 1 to the index, so it will be minus 2. Minus 3 plus 1 is minus 2. We divide by the same number plus a constant is the answer. So let's look at another example. Here we want to find the integral of 2 on x squared with respect to x. The coefficient, well, before we integrate, we will write this integral in a more convenient form. So it will be 2x raised to the power minus 2 dx. We will write it in a non-fractional form, the 2 on x squared term. Now the constant 2 will remain the same. We look at the index. Index is minus 2, so we'll add 1 to that index. So we will have minus 2 plus 1 is minus 1. We will divide by the index plus a constant is the answer. Example 5. Here we have the constant outside the integral. It makes no difference if this constant is outside the integral or inside the integral. That constant remains the same. So we'll write 8. The index is 7. So we'll add 1 to the index to make it 8. Divide by the same index, which is 8. The new index, which is 8. And we'll add a constant, so we can simplify this to x raised to the power 8 plus a constant.